So we are going to find out the matrix, we are going to find out the transformation matrix and find out what is this G cap. G cap is nothing but P inverse GP and H cap is nothing but P inverse H. That can be obtained easily from the transformation matrix, where x of k, if I replace it with p into some other vector, let me say y of k. Now if I replace this one, what is it? X of k plus 1 is equal to p into y of k plus 1. Now if I substitute it here, p into y of k plus 1 is equal to g p yk plus h uk, and therefore if I pre-multiply it with p inverse, right, I have this y of k plus 1 is equal to p inverse gp, which is gk plus h cap u of k. That is what I have written it here. G cap is p inverse gp and h cap is p inverse h. H cap is p inverse h. Now these two transformations, now I can see that if I pre-multiply it with p on both sides in this equation, therefore this is in identity matrix, therefore I can write gp is equal to p g cap. gp is equal to p into g cap. And similarly, what is h here? If I pre-multiply it with p on both sides, then h is given by p h cap. Now we will work on these two equations separately. Now remember, p is these matrices. P matrix is this one. Now gp is equal to pg cap. gp is equal to pg cap from this equation. gp is equal to p g cap and h is equal to p h cap. Now what is g cap is what we are going to find out here from this equation. Now g into p, what is p? f1, f2, so on, fq, vq plus 1. All these are vectors. I am not writing the bar sign here. G into p is equal to p into, again, f1, f2, so on, fq, vq plus 1, so on, vn into g cap. Now these two must be equal. The left hand side of the story and the right hand side of the story must be equal always. So when these things happen, now let us see what is how do you get a g cap. Now multiplying this, now this is a column vector, f2 is a column vector, all these are column vectors. You have column vectors, the f11, f21, second row first column, f31, f41 and so on, fq1, right, because f is a q linearly independent column vectors. So f is a first linearly independent column vector. Similarly, you have q number of f vectors which are column vectors which are linearly independent, right. So these are the things, and the remaining from q plus 1 till n, it is 0. Therefore if I multiply it with g, what is happening here is I have g cap, we get, after multiplying all these vectors, we have g cap as g11, g12, so on, g1q, similarly g1q plus 1, g1q plus 2, so on, g1n. Similarly g21, g22, g2q, g2q plus 1, g2q plus 2, g2n. So similarly gq1, gq2, G Q Q, G Q plus 1, Q plus 1, G Q plus 1, Q plus 2, G Q plus 1, N. And the nth vector Gn1, right here. Now this is Q, this is Q. Okay, these are Q vectors. Now you can say I will divide this, or partition can be done here. Okay, now this vectors, because of linearly independent column vectors, here I have everything 0, 0, 0, 0. Okay, now here I have this is the n q plus first row, and q plus 1, G q plus 1, q plus 2, so on, G q plus 1, n. And as a whole you can write Gn q plus 1, Gn q plus 2, Gn. So this is a vector. Now this G cap you can write it as G11, G12, null vector G2. Right. So G11 is this vector, G12 is this vector, 0, this is a 0 vector, and G22 is this. Now if you consider any equation where you are having values, right, and you can find out these values to be satisfied. So G cap is this one, right. Similarly we have H cap. H is equal to P into H cap. Now H is equal to P is again F1, F2, FQ, VQ plus 1, Vn into H cap. Right, and H cap is again, because these are only linearly independent column vectors, and we are having this H cap as H11, H21, so on, HQ1, then 0, 0. This is the vector, that is H cap. So H cap can be, again this is G cap, and H cap can be written as H11 and 0. H11 and 0. Now when we are going to find out the characteristic equation, because we are going to find out the eigenvalues, and these eigenvalues of the original system, this is our original G and H are original systems when you are using the feedback, and using feedback you need to go for pole placement, and after transformation what is the matrix that we are going to get? After transformation we are going to have an equation where we have these two. G cap is equal to G11, G12, 0 and H cap, and after transformation we are going to have the characteristic equation to be G cap plus H cap into K. The determinant must be equal to 0. Now after applying this Z into, I can say we have IQ 0, 0, I n minus q terms, okay, minus G11, Z11, G cap is that one, G12, 0, G22. This is a partition again, this is also a partition, this is Q by Q matrix, this is n minus q by n minus q matrix, right, plus H cap, H11, this is again a partition, and K is a vector where you are going to have K11 and K12. K12. Now the determinant of this must be obtained. The determinant of this must be obtained using this equation, and this must be equated to 0. Now when we multiply this, what am I getting? Z into IQ minus G11 plus H11 K11, that is one matrix, and 0 minus G12 plus H11 K12, then 0, Z into 0 minus 0 plus 0, then this is a 0 vector. Z into in minus q minus G22 plus 0 into K12. So we have this. If I get the determinant of this and equate it to 0, what do I get? I cross multiply these two and obtain Z IQ minus G11 plus H11 K11. This is this matrix into Z in minus q minus G2 must be equal to 0. Now this is the equation which we are going to get. Now you can see that this matrix K is contributing or trying to get the feedback from all these G11 values, but here we doesn't have anything that is related to K. Therefore there are few eigenvalues which cannot be controllable, which we are not able to control when you are going for feedback, because initially what we have assumed that there are few eigenvalues which cannot be controlled, or few state values which we are not able to control. And here in this equation you can clearly understand that the K matrix, which is given as the feedback, which is a feedback gain matrix, that is having some control over so many values of this G11, and in this there is no K matrix. Therefore it is not able to control the few matrices or few state variables. That is the reason why it is necessary for the system to be completely state controllable, and this is a necessary condition. This is a necessary condition. What is the necessary condition? Necessary condition is that the system, the linear time invariant system, must be completely state controllable for the system to get a matrix K for the pole placement. Okay, so this is the necessary condition. Now in continuation to that, we will go and see what is the sufficient condition. We will find out what is the sufficient condition.